Hello.
In another room. Oh. Something. Oh,
No, it's the same thing. These are everything that's remaining. All right. I'm trying to decide how should these be distributed, by questions or by random. Favoritism?
How many are there?
1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9.
More than 9.
If 5 people don't.
Okay. Is there someone who really wants a pineapple cake? Okay, well that's definitely less than 9. 1, 2, 3. I count 3. Anyone else? 4, 5, 6. Okay. 7. Okay. All right. Well, 7 is less than 9, so everyone who really wants one can get one. Do you want to just come up and grab one? Because last time was kind of a disaster. So just come up and grab one.
Are there
Also, only come down if you raised your hand.
What's
Are
the
there
difference?
different flavors?
This is cranberry, and then
Okay, cranberry, this one.
and everything else is like regular.
Thank you.
There's different brands.
Which one do you think is better?
They're both pretty good.
Thank you.
Yeah, no problem. All right, last 2. Anyone really want one? If you really want one, come grab one. Yeah, come grab one. Yeah, no problem. Anyone else want one? Last one. We should have just auctioned these off.
Thank you.
Last one. It's a cranberry flavored one. Okay, awesome. Here you go.
What is it?
Pineapple cake. All right. So, hi everyone. Today is the first day. It is Tuesday of week 7. So remember that this class only lasts 9 weeks, and because this quarter is really special, Thanksgiving happens after week 9, which means we'll be completely wrapped up by Thanksgiving. Okay? Yeah, Thanksgiving is coming up. Just a few announcements about the assignments. So if you had any troubles with assignment 2, part A, the internet test, Anna should have emailed you already. So if you have further troubles about that, please let us know. Also, we're not super strict about the part A deadline. All we really want to check is to make sure that your internet works. So if you haven't finished that yet, but you do want to work on assignment 2, please let us know. Okay, as soon as possible. Assignment 2 is due in a week and a half.
A week and a half.
Mhm.
Next Thursday, not this Thursday.
Okay, so let's get started working on that. I've looked at some of the submissions. The actual amount of code you write is not super long, and remember that the key idea for this assignment is to use templates, to use the functions and algorithms provided by the STL library. Okay, so if you find yourself writing a lot of code to do something that a call to an STL algorithm could do, you should probably rethink your approach. Okay, the actual code is pretty short.
And we'll also be looking for use of algorithms, use of lambdas, things like that. It should fall out pretty naturally from the assignment handout. So if anything feels like you're a little confused on how to approach it, definitely come back to us or email us with process.
All right. Last Sunday, was it Sunday? We had a assignment 1 grading party on Sunday, and the issue is not all the graders came because apparently they were grading midterms as well. So some have been graded, some have not been graded. We will get back to you on that as soon as possible. Okay, you'll definitely get them back by early next week. Okay. Oh, and then grade-wise is fairly simple. It's either yes it worked or no it didn't. Do you want to fix it? Okay. Yeah. Don't worry, we're not actively trying to fail anyone. Yeah. Okay. So today we're going to talk about special member functions. And so this week and next week, we're going to talk a lot about these important functions that we'll talk about. These are the special member functions. Why are these special? They're special because if you do not declare these within your classes, the compiler will create them for you. Okay? But the problem is sometimes the ones that they create for you may or may not be what you actually want. So you do have to know how to declare them just in case So let's quickly talk about that. So today we'll talk about these special member functions. We'll mostly focus on copying. And then on Thursday, we will talk about, instead of copying, can you move stuff instead? Okay? I would say this Thursday is probably one of the more conceptually challenging lectures. So I think you're all recovering from midterms. Bring your A game on Thursday. All right? Cool. So just a quick recap from last week. Last week, we quickly talked about operator overloading, and we discussed some of these operators that you can overload. All right, there are some really common ones like the plus, the minus, the equals, and then there are also some like pretty obscure ones like the comma and even like the brackets can be overloaded. All right, and we went through a lot of examples. I don't think I went through all the examples I had planned, so some of them are on the lecture slides from last time. I'm currently compiling the code from last time and this time, and I'll make sure I upload them by sometime this week. All right. Yeah, so then the key idea last time was, okay, well, if we declared our own classes, how does C++ know what these operators mean for our own classes? And the answer is that you can define your own by writing these overloaded operator functions. All right, so you can write like a function operator plus equals, which overloads the plus equals operator. The key takeaways from last time was whenever you overload one of these functions, remember to obey like the usual semantics of that operator. So for example, when you are overloading plus equals, you should return a reference to the original object this itself. And the reason for that is just because we want our operators to be consistent with how these operators work for normal like primitives. Okay, just so that there's no surprise for whoever is using it. Other takeaways we had were included like if you overloaded the plus, make sure you also overload minus if it makes sense, so that when someone is using these operators, they're not surprised. Oh, plus works, but minus works, even though intuitively both should exist. Another thing we talked about was if you're implementing these binary symmetric operators, be sure to do them as a non-member function rather than a member function. And the reason for that is just because if both of these are, like if in this example, if both vectors are treated equally, you don't want it so that one of them is like the this itself, while the other one is like an outsider. You want to implement them so that they're symmetric, and the reason for that is so that if you like when you use the plus, you can use them symmetrically. Okay. When you implement these functions, you should also think about a const versus non-const. So last week, I kind of skipped over this example, but if we were overloading the bracket operator, it's a good idea to implement both a const version and a non-const version. Okay, so just a quick recap, for a vector string, the bracket operator returns a reference, which lets you access different elements within the vector or lets you edit the elements in the vector. Why do you think it's a good idea to implement both a const version and a non-const version? Any ideas? Yeah, go ahead. Mm-hmm. Yeah, exactly. Because sometimes we might need the function to be const, and a good example of that is if we try to run this code. Okay, so you can see that I declared two vectors. One vector is a non-const vector. One vector is a const vector. Okay, const vectors are just like const ints or const strings. They're essentially objects which you cannot change. And the definition of cannot change for a class that you implement is you can only call const member functions. Okay, the idea is that const member functions don't change their internal state, while non-const member functions do. So if you have a const object like this, then you can only call non-const. You can only call const members. Okay, so to take into account cases where we might have a const vector and a non-const vector, let's see, if we ran this first line, this would call the non-const version over here. And this works because this would return, okay, these aren't strings, these are ints, but you can imagine we replace this with some other string. Then because we return a reference to the string, we can set that string like v bracket 1 equal to some other string. Okay? But if we tried to, if we only had the first one and we didn't have the second one, then our const member function would not be able to call this. will not be able to call this operator bracket because this is a const object. Const objects can only call const functions. Does that make sense? So to allow for our const object to be able to call the bracket notation like this, we should declare a const version as well. When using the const version, this string, the reference that's returned, is a const. So someone can't just try to do this because then you're setting a const string to something. Okay, I made a typo here. These should not be zeros. These should be some other strings. Any questions at this point? Awesome, yeah. So now you can see how like const correctness is something that's really important when you deal with your classes. You should imagine like all possible different use cases for whoever is using your class. All right, and then finally we went through this principle of least astonishment, which means when you implement these operators, do have them work so that they work just as what you would have expected. Okay. For example, one key takeaway: probably don't overload the comma operator unless you have a good reason to, because no one really knows what the comma operator does. All right. If you're overloading the plus sign, you should probably also implement the plus equals, because intuitively, if you can add something to an object, you should also be able to add two of them together. All right, let's do a quick review of the constructor and destructor. I know that 106B and X covers this very thoroughly, so I'll essentially rush through the review part, and then I'll go to the most important part about constructors and destructors. So here's the constructor and destructor that we'll implement for string vector. Just to do a quick recap, string vector is basically just a vector of strings, and its private members are an array of elements, a logical size, and an allocated size. Right? If you started on priority queue, you should know what logical versus allocated means. Logical is how many elements are actually in the vector. Allocated is how many elements can we put in the current array. If we need to exceed allocated size, then you have to enlarge the array somehow. Okay? Yeah, priority queue will have you implement that. So we won't go into too much detail about that. But the key part is that we have this we have this array of elements. Now, inside the constructor, as y'all know, when you implement a constructor, you have to initialize all your members. So in 106B, for example, you would probably write something like this. You would probably write, okay, let's set logical size to 0. Let's set allocated size to some initial size. That's a constant, I think. And then you set elims to something else like that. Okay. Now, this normally works, and for the purposes of 106B, you should implement something like this. But this runs into one issue. Okay, and it has to do with const correctness. What issue can you run into if I try to declare a const vector? Any ideas? Yeah, exactly. If you declare a const vector, what that means is after you've when you've created that vector, you're not allowed to change any of the members, okay, even within your class. So if we do that, then we've essentially declared the variables, but then we assign the variables to something, and we're not allowed to do that. Okay, so then the key idea that we're trying to introduce here is this thing called the initialization list, where initialization list, what it means is as it declares these private members, it's also initializing them directly. Okay, it's the key difference between declaring a variable like this, const int I, and then trying to do I equals 3. Like, you're not allowed to do that, but you are allowed to do const int I equals 3. Right? As you declare the variable, you're also simultaneously initializing it. Okay, for a const variable, you have to do them simultaneously because you're not allowed to edit it after you've initialized it, after you've declared it. All right, so this is the same idea over here. If you have a const vector, then this variable is const, so you're not allowed to edit it after you've declared it. So the idea of putting it into the initializer list is as these variables are being declared, you simultaneously initialize them with these values. So instead of assigning them over here, we're just using the initialization list. Okay. Any questions? Okay. Another useful part of this is not just useful for let's see, this is not only useful for const correctness. Can you also think of another instance where after you've initialized something, you're not allowed to reassign that variable? Anything else in C++ where if after you've initialized something, you can't reassign that variable? Static, that's true. I'm not really sure about.
Static is slightly different.
Yeah, static is slightly different.
Static has to do with like
Mhm.
what variables work across an entire class versus what works for an instance. We might cover that in a future lecture, but yeah. Good guess.
Good guess. Okay, the answer is references. So remember that when you declare a reference, a reference is kind of like an alias for another variable, right? Once you set a reference to something, you cannot reassign that reference. If you try to reassign it, it's just going to change the other variable it's referencing. Okay? So if you have something like, I was going to go into an example where instead of just a string vector, we're going to create a new vector called logged string vector. And what it does is every time it does some operation, it would write to a file saying what it's doing right now. Okay, I was going to go into that example, but it ended up taking too much time to implement. So instead of telling that, but how would you design something like that? Well, as a member of your vector, you'd probably keep like some sort of O stream, right? Like you keep like an OF stream, and then every time you like write something to the vector, you would write to that OF stream. Okay, it's kind of like a log. Every time you do something to the vector, it logs it into some sort of file. But then how would you keep track of something like that? You'd probably want like a reference as a member. And in that case, you won't be allowed to just copy like file equals whatever the file is. So in that case, you'd have to use the initialization list. Okay? So the idea is if you, whenever possible, you want to try to copy the members using you want to try to copy the members using the initialization list. Okay.
Is everyone clear on the syntax of an initialization list as well?
Okay. Yes. So the syntax is kind of weird. It's the key parts is you put this colon, and then you basically have a comma separated list where you can say, okay, I want to declare logical size to be 0. I want to declare allocated size to be that. Okay. And this is really interesting, which is oftentimes when you I think I have the example in fraction. Remember we wrote fraction last time? Yeah. So last time, if we wanted to declare a fraction like this, right, you have to use this because if you just do num equals num, it doesn't know which one you're referring to, the member or the parameter. But this is not great. We wanted to use the initialization list, in which case, if you use the initialization list, you can actually use both names like this. Okay. What this is saying is it's saying initialize the num member variable to this num, and then you see initialize denum to the parameter. Okay, this is one instance where the scoping of the different variables doesn't matter. This would compile. Okay, and you'll see this a lot. You'll see I parentheses I j parentheses j for some lazy programmer who doesn't want to name their variables. Okay. Any questions?
So I'm
Yeah.
a bit confused. So if you declared a const fraction
Mhm.
And you had it without the initialization list, it
Mhm.
wouldn't work?
Yeah, because if you had a const fraction, then Anna, correct me if I'm wrong, but if you have a const fraction, then you can't assign them like this.
Yeah. So to be clear, are you saying a const fraction or a const numerator and denominator?
Like a const fraction, like 3/4,
Mm-hmm.
let's say, and we initialize it like const fraction 3/4.
So I believe you would still be able to use it without the initialization list, because what you would do is you would create the fraction and then set that fraction to be const. The issue that Avery was talking about in terms of const correctness is if any of the private member variables of a class are declared to be const, then you can't initialize them at all without the initialization list.
Oh, so that's
Mhm.
only the case when the private variable is
Oh, yeah,
themselves
mhm.
are cons.
Mhm, yeah.
Okay.
Yeah, so you would still be able to declare like a const version of the object. That's a
Okay.
good question though.
Yeah, good question.
Yeah, one other thing that can be tricky with initialization lists, or that has at least tripped me up before, is that if you use an initialization list, you'll have to declare, or you'll have to initialize them in the order that your private member variables are declared in your class. So that's just like a small implementation tip that can sometimes trip people up.
All right, awesome. And then for the destructor, I'm not going to go too much into detail with that, but destructor, you make sure you implement a destructor. Okay, cool. Let's talk about. All right, so now let's talk about copy operations. Okay, so the special member functions that are usually generated by the compiler usually means there's a lot of exceptions, but normally you'll get these 4 functions. Okay, you'll get a default constructor, a copy constructor, a copy assignment operator, and then a destructor. Okay, so for some classes that, such as fraction, right, we didn't implement a destructor, but the compiler still creates a destructor for you. All right, I don't think it does anything, but it will still create a destructor when your fraction goes out of scope. It calls the destructor. All right, the most important part we're going to talk about is these copy constructors and copy assignments, and the key idea for those is that they're sometimes really important when you use the equals sign. Okay, so when you probably often thought like, okay, what happens if I create a vector and then I say another vector equals that vector, right? What happens to the vector you just assigned? Okay, and then the idea is that when you try doing something like that, it calls either the copy constructor or the copy assignment. Okay, the key distinction between these two is copy constructor is called when you're creating a new object using an existing object. Okay, the idea is we're just creating a copy of an existing object. Copy assignment, on the other hand, is you have 2 objects, one which you're assigning to the other one, and then what happens is that the one that you're assigning, you have to wipe everything out there first and replace it with the stuff from the other vector. Okay? One is a constructor. One is we're creating a new object directly. The other one is the object already exists. We're just wiping it out and putting a copy of something else in there. Okay? Does that make sense? Okay, the key idea is the difference between these two. And just as a quick test, let's take a look at these. Suppose we implemented the copy constructor and a copy assignment. Okay, which special member functions are called in each line? Okay, so what's the very first one that's called? And I give you a hint. Some copy constructor is called in vec0. Which copy constructor is created? Oh, which special member function is created in vec0? Yeah. Mm-hmm.
Copy constructor.
Yeah, exactly. The copy constructor, right? Because we're creating a new constructor, and because we're passing it by value, so whatever vector we passed in, a copy is created called v0 over here. All right. What's vec1? Which one is called? Default constructor. Yep. Because we're not giving it any parameters. All right. Second one. Yeah, so second one is a little tricky because this is not really a special member function, right? Like if you don't declare any constructors, that won't compile. This is just a regular constructor. Yeah, it's just a regular constructor that you create. This is actually the initialization list constructor, which we'll talk about later. Okay, third one. Okay, so this is actually a trick question. The third one is not actually a constructor. Okay, this third one actually declares a function. Okay, super weird. This is called C++'s most vexing parse. There's not too much to it other than just don't do that. And if you ask me why is this a function, not a constructor, I don't know. Okay, but Anna, do you have a good reason why this is a function?
I mean, so theoretically, you can imagine you could replace, like, take any function from any of your assignments and just replace the return value with string vector, the name of the function with vec3, and then delete any parameters. And then that's theoretically a valid, like, function prototype if you worked with any of those, where you declare it at the top of it and then you implement it later down in your code. So yeah, so this is just like an unfortunate result of function prototypes being a thing that you can do. Yeah, and if you're not familiar with function prototypes, don't worry about it, or ask us after class.
Okay. Oops, I went to the next one, but okay, which one is called over here? The copy constructor, because one of the parameters is another vector, and vec4 becomes a copy of vec2. Okay. All right. Fifth one. Tricky. Yeah, the fifth one is a default constructor. The reason why C++11 introduces the braces one is so that you don't have to do this anymore. You can just do this one, and this would call it the default constructor. Okay, I'm just gonna go through these. This one calls the copy constructor. We create vec3 plus vec4. That is some vector, and then we use that to create a copy of vec6. Okay, quick question. This next line, I don't want to show the answer. Which one is called in the next line? Vec7. Yeah, it's copy. Definitely copy something. Constructor or assignment? Okay, who thinks constructor? Who thinks assignment? Okay, so the answer over here, to think about the answer, you should think, okay, am I creating a new object that's a copy of vec4, or am I taking an existing object and replacing that new object with the stuff from vec4? Which one is it? Yeah, the answer is we're creating a completely new vector, right? This vec7 didn't exist until we declare it right now. So this actually calls the copy constructor. Okay, we're not assigning vec7 to something new because vec7 is something we create directly. Okay, this is why some people don't like this kind of assignment. Most people, some C++ people prefer this constructor because this makes it really obvious it's a copy constructor, while this, it's kind of confusing. Is it an assignment or a constructor? This is a constructor. Okay, vec7 equals vec2. Well, vec7 already exists, so we're replacing vec7. This is a copy assignment. Okay, quick question. In the return value, remember that when you return something, you actually create a new vector? Because, I mean, the vec7 is currently a vector within this scope, so you have to make a new vector to be able to pass it into the other function. So the copy constructor is called one more time when you return something by value. Okay? Any questions at this point? We just want to make sure that we know which constructors are which, so that when we implement it, we can think about what's being implemented. Okay? Cool. All right, so the problem from last time, we briefly talked about the problem from last time where when we implement the plus operator, this code didn't work. And the reason for that was because when you did the equals, okay, we never implemented a copy constructor. So when you don't implement a copy constructor, what C++ does is the compiler creates a copy constructor for you. Okay, and that copy constructor is pretty intuitive. It basically just copies every member. So for example, when you create the copy, it copies the 4, because it's a primitive, it's an int. But then it also copies the pointer. Now when you copy a pointer, you didn't actually create a completely deep copy of the array, right? You're just creating another pointer, which is pointing to the same array. So because of that, the default copy constructor doesn't do exactly what we want. Okay, does this make sense so far? Any questions at this point? Because this is really important. Okay, so when you add an element to the copy, it's actually adding to this array that's being shared between both. Okay, and then when you call the return value, it's creating another copy. So now you have 3 pointing to the same one. Okay, and then when vec and copy go out of scope, what happens? Okay, so the destructor of vec tries to free the memory here. So the array is freed once. And then what happens when copy's destructor goes out of scope? Yeah, so copy calls its own destructor, which tries to free that array twice. Okay, you don't want to free stuff twice. Okay, and worst thing is later on, this thing will be freed again, so you'll free this array 3 times, which is bad. Okay, so how do we prevent this? Well, the issue is this copy operation. So we have to implement this copy constructor ourselves. All right, details. So this is a long list of basically what the copy operations must do. But what it simply means is the copy constructor needs to copy all the members, and then particularly when it reaches some member that you can't just do a simple assignment, you have to figure out a way to deep copy it. Okay, so let's implement our string copy constructor. Oops, I have my answer over here already. Okay. All right, so this is just a constructor, right? We're making this a constructor, but the parameter it takes in is a const reference to another vector. This makes sense, right? We're creating a copy of some other existing vector. Okay, and then we go through all the members that we can easily copy, the ones that we can just copy using the equal sign, and we use them in our initialization list. So here, logical size should be the same logical size as the other logical size, and then allocated size should be the same size as the other allocated size. Okay. What's interesting is that these are private members. So when you're implementing this copy constructor, you're actually allowed to reach into the others, private members, and copy stuff from them. Okay, just an interesting thing to note. But there is one thing we can't just simply copy, and that's the pointer itself. So how do we make a deep copy of that array? As a head, when you do PQ, you'll have to do this as well. So hopefully you've been thinking about it. Have people started PQ? Okay. Okay. Nice. All right. All right. I guess yes. Mm-hmm.
You just have to like new with the allocated size,
Mm-hmm.
and then you have to make the new string vectors pointer point to the new array that you just created, and then you have to element by element copy it.
Mm-hmm. Okay. So. Great. So essentially, we have to create a new string vector. So new std string. What's the size? Yeah, just allocated size. Okay. And then elims is already the pointer. So we've also set the pointer point to a new array. We have to perform element by element copy. How do we do that? And I hope you're not thinking for loop. Yes, right? There's an algorithm called copy. Okay, well, what do we pass into copy? What's the range we want to copy? Other.begin, nice. To other.end. And then what are we copying into? Yeah, so essentially copying into elims, right? Or because this class we've written also supports begin, so we can just call begin. Begin would give you the iterator to the very beginning of the array. Okay. And that's it. Pretty straightforward. Questions? Yeah. Uh-huh.
What's no except?
Okay, good question. So I was trying to compile this, and apparently if you want to compile this in a really modern like C++ compiler, you have to specify this word, which basically means the constructor can't throw exceptions. Okay, you can imagine weird things happening if a constructor throws an exception. It's kind of like, okay, did you actually make a copy or did you not make a copy? Not really sure. Okay, I have to experiment with this a little more because I didn't know you had to put that until like 20 minutes ago when I tried to run this. So yeah, I have to double check on that. But apparently you have to put this no except for it to compile. Okay, if you use like older compilers, I don't think you need the no except. And could you check for me? Okay. Because I was surprised to find out that you have to write this as well.
Yeah, it's in C++
11? Okay. Yeah, but this makes sense because then if you can, if you don't know if an exception will be thrown, then because you don't really know if an exception is thrown, did I actually allocate memory or did I not allocate memory? Not sure. Right? So you have to specify no except to say, okay, I promise I'm not going to throw an exception. So you can assume that when this function is done, you've allocated memory. Remember to free it. Okay, and that's it. Let's talk about copy assignment. So copy assignment is a little different because copy assignment is not a constructor. Copy assignment is simply you are taking you're implementing the equal sign. Okay, so remember how do we implement how do we overload the equal sign? Well, you would do this syntax, string operator equals, right? And it has some return value, and it also has some number of parameters. Okay, so think for a moment, talk to your partner, and discuss what the return value and the parameters are. Right? When you use the equal sign, what do you expect the parameter to be, and what do you expect the return value of the equal sign to be? Talk to your partner. 30 seconds.
The parameters would probably be like both steps because so like symmetry instead of
Right, because you need a sign.
I'm not hearing a lot of talking in the back. Are we shy or tired? All right, so what do you think about the parameter? What should the parameter be? Okay, so think about how we're calling the copy assignment operator, right? The copy assignment happens when you have like a string vector v1 and a v2, and then you want to set v1 equals v2, right? If we rewrote this in the operator form, it would be v1 dot operator equals, and what's the parameter you would pass in here? Right. Remember that in these member functions, you pass in the right-hand side as one of the parameters. Okay. So this would be you would pass in a vector also, string vector other. Okay. Const or non-const? Right. The equal sign shouldn't change the right-hand side. Right. That would be a really weird equals operator. So make sure you pass it as const. Okay. What's the return value of an equal sign? Same thing. Okay. Which would yeah, you're right. What do you mean same thing?
same type.
Yeah, the same type. String vector. Okay. Do we pass in? Is it a copy or a reference? Reference or copy? Yeah, it's a reference. Okay, and it's I mean, so usually you don't want to write code this way, but technically you can do something like this. You can do v1 equals, and then v2 equals v3. So what this does is it assigns v2 to v3, and then it assigns v1 to v2, because this thing evaluates to a reference to v2. Okay, you'll see this a lot in really bad C code. If you look at really bad C code, you'll see like assignments chained together. So just so that people aren't surprised if they try to write code like this, make sure you return a reference to this. So we already know that at the end you return a reference to this. Okay, how do we copy everything over? Any ideas? Just as a high level, what steps do you have to do to copy stuff into an existing one? Yeah, go ahead.
For like the logical size, you just need to copy the thing. But for the array in the list might be a different size, so you can make sure it's the same size as the array instead.
Okay, so copy the logical size, copy allocated size, and then make sure you create a copy of the array.
Make sure the array's like lengths are the same.
Okay. Make sure array lengths are the same. Yeah. The one thing that we'll be doing is you're essentially just completely erasing whatever is in the original one. Okay. So it's a little simpler to just do something like change elums to a new array of size, allocated size. Okay, so at the end, we're going to change elums to a new array of allocated size, and then we're just going to copy elums from other to this. Okay? But before we do that, there's something we have to do before. Right? Because we're changing elums to point to a new array. What happened to the old array? Yeah. Yeah, remember to free it. When you do a copy assignment, you essentially have to destroy everything that was. You have to free all the resources in the old one, and then you can set the new resources in. So here, make sure you free the old vector. Okay, let's just quickly implement this. How do you free the old one? Well, you can just say delete elims, and then we create a new array. Elims equals new. Yeah. So yeah, remember that arrays aren't resizable. So so you have to basically just delete the old array and create a new one. New std string allocated size. We don't have. Remember to copy everything as well. So allocated size equals other dot allocated size, and logical size equals other dot logical size. Okay, quick question. Why can't we use an initialization list here? Because it's not a constructor, right? Remember you can only use an initialization list when you're initializing something completely new. This is a operator which is just overwriting stuff, so you can't use an initialization list, right? Which means the code looks a little uglier than this, but you know, whatever. All right, are we done? Give one more step. Remember to copy everything over. So copy other.begin, other.end, and begin. Okay. Am I missing anything? I think I'm set. Now, there is one weird edge case to be careful of, and that's when you do something like this. And technically, this is allowed. What if you do v1 equals v1? Okay, so it's self-assignment. You're setting v1 equals to v1, right? What happens to this code right now? Okay, so it deletes itself, and it tries to copy everything from the delete itself to the new self, which is not allowed. Okay, so in cases like this, you basically just want to check: am I trying to assign to myself? If I am, then just don't do anything. Okay, so the code you'll usually see is, okay, make sure that this is not the other one. Make sure that this, so this is a pointer. So how do we compare this to other? Okay, equals ampersand other, yeah, exactly. So remember that other is the vector itself. This is a pointer, so you want to check if the pointer is equal to the pointer. Okay, just a quick question. Why can't you do this? I was thinking about why you can't do this the other day. Any ideas? Yeah. Oh no. Go ahead. Yeah.
Oh, it's just because isn't this like just a location in memory versus it trying to compare it to a whole object?
Right.
So, do we implement double equals?
Good point. So yeah. Yeah. So both are good points. So yeah, this requires string vector to be implemented to have the equal sign implemented, and we don't have that. Well, not necessarily. We don't necessarily have that. So just in general, the correct way to check is using this. Yeah. Question?
Yeah. You can also have a weird scenario, right, where like you get two string vectors A and B that both have the same values but are in different places in memory.
Yeah. Yeah. Great point. So we're actually checking if the pointers are pointing to the same thing. All right, and if that's the case, then actually it's usually implemented like this, where if it's not equal, then do all this. But then no matter what, still return the vector itself. Okay. Questions? Yeah. Go ahead.
Is and other dot begin, like, do they point to the same thing, or are they different?
Other dot begin versus begin.
No, and other.
And other. Oh, this one? You mean this one? You mean?
Yes.
Yeah. So this is saying if the left hand side, if a pointer to the left hand side is the same as the address of the right hand side.
Is the address of the right hand side the same as the address of its starting point?
Not necessarily, because the vector. So because the vector itself, you don't know exactly how it's storing the elements. It's storing the elements somewhere else, right? But then the actual object itself has an address. I don't have a diagram. Let's see. Here's a diagram. this and ampersand other, this and ampersand other is referring to this address, the address of this thing, and the address of this thing, right? But then you're not necessarily comparing like where the array itself is, because the array itself is over here. Yeah, so we're just checking if this address is equal to this address. If they are, then they're the same vector. Any other questions? Yeah, go ahead.
So the allocated size and logical size can be const member variables.
Good point. So yeah, these can't be const member variables, and the reason for that is because, I mean, if you're copying something, then it's really hard to make stuff const in it, because then you're trying to copy stuff to a const, something that has already const members. So yeah, you can't, those can't be const, and especially in this case, those can't be const either because you're implementing a vector. Yeah, good question.
If you wanted to do something where you had like a const member variable, then what you could do is just within the assignment operator, you could not assign it. But remember that in the copy constructor, you could still assign it. So in this case, if you were to say we wanted, say, logical size to be constant, then we could make it const, assign it in the copy constructor, but then when it comes to the copy assigner, copy assignment, then we just don't have to set it again, because we know it already exists and has the correct value.
All right, so in the last few minutes, just want to briefly mention something that you can do, but you know, you might see this sometimes, which is, yeah. So in some cases, where you don't want to be able to copy your object. For example, for an if stream, people say IF stream. For an IF stream, you're not allowed to copy an IF stream, right? Because the IF stream itself has it has like a file it's reading or writing from, and you're not allowed to copy that. So to prevent something like that, you are allowed to say that copy constructor equals delete. And what it does is it tells the compiler, hey, don't even declare a copy constructor for me. Okay? If anyone tries to use my copy constructor, throw a compiler error. All right, just quickly, rule of three. So when do you need your own special member function? When the default one doesn't work. And when does the default one not work? The default one doesn't work when your class uses some resource that it has ownership over. Okay, so for example, if you have a pointer, you're assuming that your class itself has ownership over whatever the thing is pointing to, right? No other class should have ownership over that thing. If you try to do just a simple copy using the default one, it will copy the pointer, but it won't actually copy the resource. Okay, and this is true across like different kinds of resources. For example, file streams, the reason why you can't copy them is because when you open a file, you have ownership over that file. In most cases. So yeah, so there are a couple other common reasons you might want to, you might have ownership issues. So when that happens, the rule of three, which is a really common idiom that you'll see, is if you define or delete either a copy constructor, a copy assignment, or a destructor, then you should define or delete all three. Okay? If one of them exists, then all three must exist. Can anyone think of the rationale why this might be the case? Okay, and as a hint, think about when you need to declare a destructor. Yeah, go ahead. Mm-hmm.
When you copy something new into like a variable that you've already created, now you've got a bunch of, in the vector case, you've got like a whole allocated array now that's just sitting there in memory, not being freed, so you need to have some sort of destructor.
Right. Yeah, exactly. You implement a destructor when you specifically need to do something special to take care of like the ownership issues the pointer has. So if there is an issue you have to handle yourself in the destructor, then that same issue will appear in the copy constructor when you want to make a copy of the pointer, and when in the copy assignment when you want to replace another pointer and make a copy. Okay? So if you declare one, you should declare all three. Okay? Now, the thing is, you won't hear rule of three anymore. Now it's called rule of five. And because next on Thursday, we will talk about two other special member functions. Okay? There's also this thing called rule of zero, which means if the default ones work, then don't declare them. Okay? So for example, in the fraction class we wrote, there were no like special resources we have to handle. So don't declare any of those three special member functions. Okay, it's clean and you won't make a mistake if it works. Okay, small problem with copying, and I'm just gonna go over this really quickly. But suppose you had this code right over here, which essentially takes it creates a vector of words. It reads a bunch of words into the vector. It returns the vector, and then it assigns this local variable to that new vector. Okay, does the code make sense? This is probably what a lot of you wrote for like n-grams when you have to read a dictionary. Okay, now the question is how many vectors are created in this whole thing? So I'm just gonna run through this, okay? So in main, you create over here, in main, we create a vector words. So there's that over there. Then when you call find all words, you create a local variable words, which has an array. We populate it with something. When you call return, a copy is made. A copy is made so that you're able to return the value. And then when you do the assignment over here, equals over here, we call the copy assignment over here, which copies that array one more time. In total, how many vectors are created? 3 different vectors, 3 different arrays. Okay, which if you think about it is kind of pointless, right? Why are you copying so many times? It literally is the same array. Okay, now in practice, there's this concept called copy elision and return value optimization. What essentially does is if the compiler is smart enough to know that when you are returning this vector, it knows that you're going to return the vector anyways. So when you create that vector in the local scope, it actually creates it inside the stack frame for main. So you can see that it essentially skips this like local vector over here, so that so that only the copy assignment operator is called. Okay, notice that using copy elision, we skipped one vector. Okay, but the question over here is, can we do better? And a potentially even better idea is, okay, instead of doing all that, can we just we create a vector over here, we create that vector over here, but instead of copying everything over, can you do something like this? Let's get rid of the old array, and let's have the first vector words. Can it steal this array it has over here, and then it can evict the other one, so that it's basically stealing its resource. Okay? Yeah. So next week, or not next week, Thursday, we'll talk about this new concept called move semantics, which is essentially the idea of instead of copying, can you move stuff around? Because moving is much more efficient. Okay? We'll talk about how some people say move semantics is kind of like talking about stealing and evicting other people's houses, and it's kind of true. We're stealing resources from another variable. Okay? Questions to ask. Moving and copying is a very deep thing that you really want to think about before you do it. So that's what we'll be doing next on Thursday. Okay? If you have questions, meet outside. Otherwise, thanks for coming, and I'll see you on Thursday.